Our speaker this evening has over 30 years of industry experience, formerly at companies including Neo4j and SendMail. Please welcome the Couchbase VP of Product and Solutions, Jeff Morris.
All right, so thank you everybody for coming out. I'll try to make it as fun as possible. I've got a tough act to follow, but we're going to talk about AI. We've coined a thing called adaptive applications. That's just applications stuffed with AI. And then we'll talk about what we're seeing right now as sort of the key issues going on, and how to start to resolve some of those and move forward. Right now, it really feels like we're in kind of the era of, with Gen AI, of chatbots and coding assistants. Right? You got your Copilot and everything, but that's kind of where everything is. The odd thing to me, because we've been shilling AI for since like July, 4th of July last year was when we were like, we got to get on this train. Because of course, all right, my first question for you guys is, who knows about Couchbase prior to this? Thank you. Okay, that's really good. I was expecting 2 people. So of course, I'm the marketing guy, and that's one of the biggest issues. It's just general awareness of Couchbase itself. As we stated, the origin story I'll get into in a little bit. It was really the marriage of the curators of Memcached and the curators of CouchDB. So Membase was where the base comes from, and Couch1 is where the couch part comes from. So when you really look at us, we were kind of the original multi-model database, taking an in-memory key-value database and jamming it together with a scalable document store. And now when you look at kind of how the trajectory of the NoSQL market, everybody arguably is following what we were doing back in 2011. Since then, we added things like SQL query. We added things like text search. We added things like analytics and eventing, so having data streaming coming in and out of the database. So again, arguably, we're one of the original multi-purpose databases. But with that original origin story, I'm like, the way to characterize it is it's sort of like when peanut butter and chocolate met, right? It's the combination is better than the original couple of pieces. Anyway, so I'm very excited the fact that you guys do know about what Couchbase does. I'm going to remind you a little bit. It is an application. It's a database that you use every single day, all the time, right? When you're looking at your LinkedIn feed, all of your feed is cached in Couchbase. When you're getting a fraud detection warning from your bank, the odds are that there's 2/3 of the world's credit card companies. Or the world's credit card accounts are being managed in the FICO Falcon application, which is powered by Couchbase. When the Pepsi driver is delivering your Fritos and your Tostitos to your supermarket, all that routing is happening via Couchbase. When if you're buying a really, really nice handbag for your mom, because it's Mother's Day coming up, and you walk into Louis Vuitton and you want to make it really ultra special, their whole selling ceremony when they deliver you all of their inventory worldwide on the tablet is going on through Couchbase. You go on a Princess Cruise, they give you that little medallion that is your room key and your payment device and the thing that tracks where your kids are. That's all powered by Couchbase. The Princess Cruise ships, they have something like 15,000 sensors on board. So they know where you are and what you're doing. And in fact, the Princess Horizon ship, when the pandemic hit, right, the way when they just left them offshore for like 3 weeks, what they were doing in terms of contact tracing was figuring out who was standing next to each other in the buffet line, right, and then isolating, if someone's sneezy, isolate them, and then the 3 or 4 people around them. So, like I said, you're seeing Couchbase everywhere. Your Apple ID, your American Express membership ID, your Bonvoy card, every airline ticket you ever purchased that went through Amadeus or Sabre, it's all Couchbase. So you see it all the time. It's invisible though, right? Even this particular slide that I'm showing here, right? The way I teach all our folks about what we do So I say, look, we're all about account profiles. Because the reason you would adopt a JSON document data store is because you want the flexibility as a developer to manipulate the data, right? You don't want to be stuck on a fixed schema where you have to go beg somebody else to, can I roll out a new version of the schema, add a column, and that affects the entire user base. JSON document databases, right, ourselves, Mongo, DocumentDB, et cetera, introduce this degree of flexibility where the developer's like, I don't have to ask permission of anyone. I can just go and make my changes. I can recognize that in the account profile for me, I like blue. So sell me blue stuff and make blue stuff kind of offers to me when I'm interacting with the application. So the reason why we fit so well in all of these things, like and you'll see us in your Hulu ID, your DirecTV ID, your Peacock ID, all of that's still us. So you take your account profile and then match it up to whatever any one of these vendors, their big catalog of stuff is, like Yellowstone or Tostitos or your feed. Match it up to that big catalog of stuff and make that experience better. That's what is a very, very typical Couchbase style application. And again, you'll see it and interact with it everywhere. Packages, right? Every package that you ship on UPS and DHL, running through Couchbase. So I like this slide because it also, I have 8 customers there. That represents 7.5 billion account profiles. We counted, but we generalized. We didn't go count 7 billion. But that's just shy of the entire population of the planet. And like I said, it didn't account for your iPhone ID and your Amex and your Amadeus. Those are just the A's. So again, you'll see us all over the place. So it's been a really fun kind of company to work for. I've been there 4 years. As we said, I worked at Neo4j before then, really into graph databases and how everything's interrelated. And then sort of feel like we hit the big time with what Couchbase does. There's a couple of things, reasons why people end up deciding on us when they're evaluating databases. Overall, Couchbase is really fast because it came from that memcached heritage. So it's an in-memory store. Everything that goes on in the database is memory first, whether it's identifying where each node that's running a replica of your data for safety's sake, writing to that, reading from it, always knows, all happening in memory. Replication happens at memory speed. So customers, when I surveyed and asked them, anyone using Couchbase now or have used it before? So
I guess arguably if you have a LinkedIn profile.
Yes, exactly.
Yes.
Okay, so develop something on it. Maybe I'll change the question, right? Develop an application with Couchbase underneath it. So the reason why customers pick us is performance. We're really, really fast. Generally,
quick question.
Yes.
Are there any game company using Couchbase?
A ton of them. It started with Zynga, right? Your original Farmville was a memcached application that moved into Couchbase. And now there's a huge amount of other gaming products that are in there, including on my last slide, EA Sports. So yes, gaming, perfect application for it. Remember, it's account profile, what are they doing, how far along has it been, and the whole reason why you end up doing it is because A, it's fast, it gives you a really good user experience, that's this bullet. But the second reason is, again, the JSON format gives you the degree of flexibility to program whatever you want without having to go and make major changes to the database. And then as I mentioned earlier, right, then we support all these different data access patterns that, if you know SQL, you're going to like Couchbase because SQL++ is SQL. It's just SQL for JSON. We wrote the book on it. There's an open source project, DB, is also supporting it. I'm spacing on DynamoDB's particle is also basically based on SQL++, all written from the same set of contributors. So I like the flexibility of being able to change and modify things in the app to keep delivering this killer user experience. They like mobile, right? We have a mobile embeddable database called Couchbase Lite. That's what the Pepsi drivers are using to onboard the truck to make sure that your route is correct and your inventory is proper for getting into every supermarket that they're delivering to. But the cool thing that the mobile thing does is we have customers like Emirates Airlines. They take a hardened tablet, so they've reinforced it. They have hard storage, multiple storage mechanisms on the device, but they use and run their pre-flight checklist on Couchbase Lite, and they synchronize it to the cabin crew, to the maintenance crew, and to the people who are boarding the aircraft, in order to make that whole exercise of getting people on the plane really, really efficient. Now, of course, we all know that internet connectivity at the gate is terrible. So what Couchbase Lite happens to do, and the thing they bought into, was if we had a local network, like the network on the plane, the devices themselves can synchronize data amongst each other. So it's basically like a last in, first out kind of design, so that whenever the pilots say yes, everything's okay, and it syncs to the maintenance crew tablet, and then when the maintenance guys get back to the hangar where there's good connectivity, everything syncs back to the home base. Peer-to-peer syncing is what that's called. It's interesting, I also have mining companies that are using Couchbase, so heavy equipment going down underground, same premise, right? A local network amongst the machines, everything synchronizes there. First machine out is the one that is synchronizing it back to the home base. So really, some clever stuff in mobile. Gaming is huge in the application use of our mobile database. And then so I brag a little bit about our performance. I perform really, really well at scale. We've hired third-party vendors all over the place to be like, try it out, tell us. Against many, many other systems, generally we come out very, very competitive. And so I'll kind of race anyone, especially as you grow your user communities. Couchbase gets better and better and better as you go. Anyway, so that's kind of the why people have been using us in the past. And here's an example of all the applications that are using Couchbase as they're presented on your phone. You probably recognize all of them. So here's the interesting thing about what makes Jeff able or relevant in terms of talking about AI as it evolves. So we've kind of started out with this performance-powered application kind of notion, right? The in-memory speed of the system, the everyday applications that are using it, like LinkedIn. But then we continue to see applications themselves evolve over time, where the experience-driven notion of these applications really starts to take over. So being able to cache a user session and match that up to their JSON document and modify their profile, and do a text search on whatever they're looking for in a product description, and be able to jump the relationships of, within that to see have they ever bought anything similar to this in the past, or do things like capture time series change events. Right? We did a really clever thing of just modify a JSON array to collect time series data, and then use that as a mechanism to both feed the document and then unwrap it when you needed to perform analysis on it. So these experience-driven applications, again, are a really big deal to us. You've got analytic-driven applications like Domino's. They took all of their point-of-sale information from all their stores all over the country. And before Couchbase, it used to take them about 3 weeks to analyze that and then figure out what the next set of offers is going to be. Does anyone like the barbecue chicken pizza or not? Is really what they're looking at. So they're doing that. When they picked up Couchbase, we got it down to about 3 days turnaround time. Arguably, that's not good enough. So as I start to talk about this adaptive application, this AI-powered applications, there's a notion of gathering real-time information and being able to use that immediately for particular situations. I'll give you an example using Domino's. So in the National League Championship Series back in October, the Dodgers were playing the Diamondbacks. Right? Dodgers, of course, are the powerhouse. Diamondbacks are the underdog. But the Diamondbacks are up like 3-2 in the series. And so the Dodgers have a really, really critical must-win game. Clayton Kershaw's on the mound, right? Lefty pitcher, 3-time Cy Young Award winner. He's awesome. I hate him. I'm a San Francisco Giants fan. So Kershaw's great, except on that day. He gives up 11 runs in the first inning. So Domino's, had they had like real-time information that they could have, and situational information that they could have used at that moment, without having necessarily human intervention taking over. What Domino's would have liked to have had is, hey, look, now that I know the game is basically over after the first half hour, how about if we abandon our sales offers in Los Angeles because they turned off the game, pivot to Phoenix and Arizona for the Diamondbacks, and San Francisco because I'm cheering it on, maybe New York as well. So pivot to different areas and make the offers of the only set of people who are going to be able to actually continue with the game. Now the interesting thing about that is, imagine if you're going to make that pivot, you better be sure you can actually pull it off. So they want to know, do I have enough dough in all of those locations to actually do what I want to do here? So they want perhaps a live inventory calculation, right? Location based. They could do that. They want to make sure they have enough drivers on call, or do they have to go and hire DoorDash people to take over? So those kind of decisions of being able to react in real time to these situational events, right? Take over and be able to serve your customers in these particular new ways. That's what kind of we're going for as I lay out what this adaptive kind of application is. Of course, I've already mentioned it could be really great if it was on mobile. And of course, mobile's really helpful here because mobile devices contain an immense amount of really interesting data for doing this hyper-personalization kind of idea, like where you are, situationally, the fact that we're together, right? That you can figure those things out. So who you're with, maybe what the weather is like, or what news event is going on that is going to trigger some kind of reaction or some kind of change. So our goal is to help you guys make applications that are indeed able to make this pivot or make this kind of change. So that's what I want to talk about as we discuss what adaptive applications are going to look like and what kind of the requirements are for them. And you can tell me I'm full of it, or as we go through this, you're going to be like, not so bad. So fundamentally, as I just said, it wants to operate interplanetary, all over the planet, which means ultimately it's got to be mobile. And that mobile information, none of us want any kind of spinning wheel, so it's got to be fast, right? Latency is bad. Networks always still suck. So do things and behave like a content delivery network, Netflix, who pushes everything out to as close as they can get to you so that the movie doesn't stop in the middle of it. Take on that same principle, right? So for responsiveness, I just discussed what that contextuality was, right? Who are you? Where are you? What's happening at that moment? When is it going on? And use that real-time data as an input to your AI-powered application. Imagine, I'm going to kind of assume, who's already kind of familiar with using Gen AI with vector search kind of capabilities and RAG kind of capabilities. We'll talk a little bit more about that, but it's really, the notion is having the ability to have a conversation with a large language model like ChatGPT from the application in order to make these adaptations happen and incorporate those kind of real-time situational information in that assembly of the prompt, right? When you're doing Gen AI work, you're basically writing your sentence or your request and feeding it specific information about what you want to get in return. So you would tell it, you're an expert in this particular topic. And then what I really want is the listing of the top 5 reasons why that topic is important, and I would like you to display it in a table, right? That could be kind of a style of prompt that you might engage with ChatGPT, and then we give you that information back. Hopefully it doesn't go nuts on you and give you a spurious, hallucinated answer, but we'll talk about that, and this notion of using AI, using vector search to help narrow in on making the data or making the prompts themselves more relevant and trying to avoid having hallucination situations come in response. So we like this hyper-personalized kind of notion, right? Making sure that everything stays accurate, making sure that everything is actually cool, right? You don't want, all of this is to try and push the idea of what's going to happen in the next generation of applications or AI after we get through this coding assistant kind of situation we're in now, or content generation chatbot kind of situation we're in now. So we're trying to think over the event horizon on a lot of this. But again, and you might say, Jeff, you're still sort of full of it, but I'm really not, because you can already see that these particular, the series of forecasts that I might make are kind of already coming true. So the use cases that we like, Amazon just announced they're going to do personalized product descriptions in their listings for you. So get ready, like I'm a coffee, I like my coffee. During the pandemic, the Burr grinder, right, changed my family's life. The coffee got so much better. Instead of using the little push button one, I broke that in like a day and a half. Anomaly classification and analysis is going to become bigger and better. Doing semantic search or hybrid search, semantic search being find me things that look a little like this, or find me things that sound a little like this, right? That's where the vector notions come into play. Hybrid search is just an extension of that, right? Do the semantic similarities search, but then combine it also with some specific search attributes. Like imagine your where clause being, where I have a range, I got a particular price for the shoes that I want to meet. And then I've got a particular colors that is the anomaly or the thing that you're looking for similarity on. And I want availability, right? So that's a geolocation search. You do all of that together. And then continue with what I've described earlier, the chatbot and content generator or coding assistant kind of capabilities. So we did a bunch of stuff over the last, 9 months or so, right? We did embed in our product this thing called Capella IQ. That's our coding assistant. It speaks SQL or SQL++. You can ask it to make a document, make data for you. You can ask it to make, when I organize data inside of Couchbase, if you want it to feel like schema, right, we have this thing called a scope. That's sort of like a schema definition. Your collection is kind of like a table. Your rows in the table would be the document. So you can organize things as you like. Unusually, this SQL++ query language supports things like joins and Windows functions and large-scale aggregations, stuff that you are accustomed to in systems like Oracle, but you don't see in systems like DocumentDB or Mongo, right? Very 3GL imperative-style languages there. So we added, this analytics service. I got a fun one. That's where we're gathering that real-time calculated information. We added vector search very recently. We've got our chatbot for documentation. And then, unusually again, we added this vector capability inside the mobile database, so that your mobile phone could have a conversation with ChatGPT or whatever LLM you want to use directly over your 5G connection, not going to up and through the cloud, but talk to the LLM immediately, get your response back. It's fast. Remember, one of the requirements we talked about was latency, right? Latency is bad. AI does not like latency. AI does not like complexity either. We'll get into that. So that's just kind of the bit that we've done. Here's what Capella, this IQ thing, you just have a conversation with, this is ChatGPT. You can pick your own LLM, Claude may be a better coder. So it's having the conversation here, and then it's making your SQL query here, and then spitting out your JSON structures down here. This is that scopes and collections thing, so it kind of feels like a traditional schema, but it's not required. So the flexibility is there. And it's got other clever things like, if you got a query, what's the best index to name? And so you just type that, use that query, and then if it doesn't exist, it'll make the index for you. So little goodies in there that customers like.
Can I just add one thing to that? The cool thing about this is when you're talking to like a chat bot, usually context is king. You know, it has to know kind of what you're talking about. It actually looks at your data. So like if your data is in Couchbase and that IQ thing goes to it, it's actually going to analyze your database and go, oh, I see what you're saying. I'm going to form the query like this so you can get it out. That's what makes it so cool.
Yeah, and the developer productivity kind of ideas here across the board, whether it's Copilot or anything else, is really pretty powerful an argument to start using these things. Imagine being able to get your low productivity developers up to snuff and to a standpoint where if they're using the chatbot or using the coding assistant, they're able to debug things directly. So sloppy code gets fixed up more quickly. My favorite developers are the kind of developers who I feed them an idea, and then at like 4 o'clock in the afternoon, and then at 9 o'clock in the morning when I see it again, I get a demo of it, right? Because the developer stayed up all night figuring it out and being like, here, check this out, right? Oftentimes that proof of concept kind of idea, which I love, right, comes along with, well, you can never implement it because there's all kinds of shortcuts and workarounds, and it's sloppy-ish. I love those developers. They live like 2 days to my every one, and coming up with very clever implementations of ideas. So we made this analytic engine. We're actually one of the weird. We did something weird that you haven't seen in NoSQL databases in a while. So we have our key value database is the thing that lives underneath the system, and that's what programmatically you can get after it. That's what makes Couchbase fast. We call the thing Magma. It's a log structured merge style database. It's fairly new, and works really, really well, scales well. But then we decided, well, what if we did that for analytic use cases? We've always had this analytic store. It's vSQL++2. It does MVP style kind of applications. But what if we actually stored the data? And so we knocked Magma over on its side and made it a column store. Still also carrying the log structured merge kind of principles of, well, it's it's writing everything up until it needs to clean up itself, and then it's constantly going through and garbage collecting and making itself compact and efficient, so that again it scales really well. So we made this column store. We separated it, the column store here. We store the data in S3, so everything can operate independently of S3. But you get SQL++, you get analytics on JSON, which is weird, and then you get a cost-based optimizer, which we patented 4 times, all in this analytics service. But here's what's cool. The cool thing is you can use things like Kafka to stream data in from other databases and catch all this information live. So when I start to talk about that real-time set of information as we're going on, it could come from Cassandra, it could come from Mongo, it could come from MySQL, and get that into your analytics service and then feed back your application. Because the origin story of Couchbase, of course, is we tend to lean towards applications, right? I'm not Snowflake. This isn't Snowflake. But it's pretty darn helpful if you're building these applications that need that real-time aggregation kind of information. The other thing that this ends up doing is when I get my result out of this, and I want to feed it back to the application, this solves like a 50-year-old problem of writing an analytic insight without human intervention. Like, I had an idea, and it's like, oh, this is great, I got to tell somebody, or put it in the app. Human intervention. Instead of doing that, you write the data, write this new aggregate byproduct back into the application and do something about it immediately. It's the analytic write-back problem that, my 30 years, I started in analytics, was always the bane of the analytic vendor, the challenge the analytic vendor always had. It's like, how do you put this thing in motion without having an individual involved? So this actually does that, which is pretty slick. Anyway, so now let's get into this AI stuff. I talk to customers, I talk to you guys all the time. You can agree with me or not, but let's kind of test drive this. What's the 2 things that everybody's afraid of AI for in using Gen AI? Or the other way I would put it is, how many people, the first time you thought of, you mentioned Gen AI in your organization, The first person to jump up and say, wait, was the lawyers. That's what, that is exactly what happened to me. But as I talk to people out there in the world, the fear of oversharing information, your proprietary information, with a large language model and having it train on it, you're like, the barn door's open, everything's gone, right? Had a great conversation with Dollar Tire, right, a vendor customer of ours. They said exactly that, that's my concern, right? You'd think that Dollar Tire, right, just a tire facility, well, they own Tire Rack. They own like Big O Tire, I think. So they're like the largest purveyor of tires both online and in retail. And they're like, our business is going to change as electric vehicles become more and more popular. Of course, EVs, when you're going through a maintenance cycle, have a lot fewer moving parts in them. Right? The engine, your engine is kind of gone. But what they want to become responsible for is all of the things that do wear out. Your tires, your brakes, your windshield wipers, your air filters, stuff like that. So they're going to be the Jiffy Lube of fixing all the stuff of your EV and then getting you along your way. Their crown jewels are the fact that for the last 50 or 60 years, every make, model, style, right, or option set of every car manufactured, they know everything. And they're like, that's our goal, right? That is platinum, that's really, really valuable to them. So the last thing they wanted is like, have an employee share that to an LLM, right? Then they're good. So this fear of oversharing, very, very high. So you've got, all right, so shared proprietary information, vector search we'll get into in a second, and retrieval-augmented generation, RAG, help solve for that particular problem. I can map out my proprietary data without you saving it, and then use that information, use the mapping, right, to give the large language model a directionality about where to look. So that's kind of what vector search does. But the other one that happens is it's still hard to trust the answer that comes back from a large language model. It hallucinates. So the way that we end up characterizing the hallucination is, well, what was that information if you were programmatically building a prompt in your application, because this is what I'm supposing, right? What if you're building a prompt from a whole bunch of databases? And it hallucinates, but you don't know which variable triggered the hallucination. How do you debug it? You're kind of stuck, right? You're test driving every one. It's like fixing the light bulbs on your string of Christmas lights, right? You're really like test it. I don't know. I give up. I'm going to buy a new light bulb. Buy a new string of lights.
But in contrast, if you have like a serial number or identifier for every single one of those light bulbs, you can know exactly which light bulb is the cause of the hallucination.
True enough. Yeah.
That far for that.
Yeah. I'll go with that. So our contention, right, especially in the world of, I'll pick on AWS, a very, very strong partner of mine. So I'm fondly picking on AWS. What I tell my partner guy, right, what I want to be is, I want to sit alongside DynamoDB and Elasticsearch and Elasticache and DocuDB, maybe even Aurora, right? All of those different data access patterns, they have their purpose-built databases, right? What I want to be is the multi-purpose database that lives alongside of all of that. So if the customer goes, I'm going to need all those features from a singular data store, especially when I'm feeding AI, how about having it come from a single pool of data, as opposed to coming from these disparate systems? That's good, but I'm with you on the identify each variable, which document data stores would be fantastic for, right? To carry forward and make sure you're not really goofing up or creating a hallucination. So this is kind of how I'm teaching my folks internally about how to think about these these particular two sets of issues. Right? Oversharing with the model, right? So what I'm trying to do here in my little example. So I have friends that live in Carmel. They go to the concourse de Elements, right? right? The car show, the antique car show kind of thing. So here's a car Gia. It's in a weird turquoise color. And we'll make the query or the requirements that, oh my gosh, wouldn't it be cool if I had shoes that matched my car color? Or for the ladies here, how about just a dress, right? And match, make my shoes match my dress. So, but there's that concern of oversharing the data with the AI model and then getting back something that's wrong or completely untrue. So I'm worried about those two things, but yet I still want to accomplish these particular capabilities. And then this is my little bit slide I just described of, well, imagine you've got all of these different systems that are feeding your microservices or feeding your application. This is the chaos kind of diagram I'll use to describe, if you're using all of that, how do you divide it, right? That's kind of the simplicity kind of argument here. So I mentioned earlier, right, having a multi-purpose database. I talk to the Gartner guys all the time. Noel Johanna, the database guy, Forrester is a good friend of mine. All the Gartner people are retiring, by the way. There's a whole new crop of folks that are coming through Stanford. So I described this earlier, starting with the origin story of Couchbase. It's the original multi-model database. We added all these different services to it to support all kinds of data access patterns with the intention both to still supply a rich set of functionality to your applications, but do so from that single pool of data. And in the context of AI, have it simplified and not confuse the large language model as you're feeding it data. So single area of complexity reduction. So we like vector search. We just put it into our product. If you've not checked it out or tried it, all it really is taking your reference information, right, plotting it out, giving it temporarily to examine this but don't save it to a large language model, and then getting back the mappings, right? That's what the vectors are, so that when I'm trying to identify these things, I can give you the clues to look, to specifically look in your model where it is, but not having overshared my data. So vector solves the first problem that I described, and you'll see folks like Pinecone and Mongo and a number of others are now supporting vector search. Our assertion
is this real results, real numbers, or this is just for illustration? Numbers.
Are the vectors specifically numbers? Sometimes, yeah.
No, is this real or?
Oh no, this is an example.
This is not real. Of course, it should be much longer.
I'll take the feedback. Thank you. So vector itself helps with use some sort of model like k nearest neighbor or cosine, find the angles that of where these things are similar, and match that first. So you preset the model with your vector information, and then use this RAG exercise the RAG technique to gather that and then reintroduce that to the model when the application's running to get your responses back, and then hopefully it's the information that you might programmatically put into a prompt is more accurate. That's the intention there. So this is what it looks like in the JSON and in the SQL++ as we're doing embeddings with vector. We've got, all right, here's the, do the KNN formula, use this particular field, use those specific vectors, that is real, in the exercise. And then, as I mentioned earlier, now make it really, really interesting. Do things like that similarity search for colors. That's what vector is going to be for. But then add in, what I really want is this to be casual and fun. So that might be a fuzzy text search. And then I want to add in a specific range search, like it's got to be 4 stars or above. And another range search, like it's got to be within my price range. And a calculated search of, well, I want it to be, within, or a geospatial search, I want it to be within a 15-mile radius of where I am, and make sure that the store has that product in inventory. All of this is what we're characterizing as a hybrid search, right, where you can compound all of these different requests as in your where clause as you're executing and talking to the large language model. A little bit comes from the LLM. The rest comes from whatever other systems you're dealing with. So here's the other observation that we're seeing. And again, this is you're allowed to disagree with me. So LLMs, there's about 15 of them that we all know about right now. There's a bunch from AWS, there's Claude, there's Gemini, there's ChatGPT and all of theirs. But what we're going to end up seeing is we're going to go from this tens or hundreds of models that exist right now. It's going to explode into thousands or tens of thousands of models. That's simply because, like each one of these LLMs as they live today, they can't keep up with the rate of change of data. There's just not enough electricity to power the GPUs to actually update them and make them up to date all the time. So that's going to trigger a bifurcation or a specialization of different models. You're going to have the psychology model and the biology model and the mathematical and physics model. Those are all going to split. They'll end up splitting apart. So then this idea of taking and feeding one LLM with that similarity notion and say, find me a similar color, super simple example. But now imagine the weather LLM getting matched up with the, the sports LLM. So, how quickly should you react if it's going to rain and you're at a soccer match or you're at a baseball game or football game? Right? The kind of combination that's going to end up happening. We're going to start to use different LLMs, purpose-built LLMs, for what they're good for. Hopefully they're staying up to date as best they can and mix and match those things. Does that make sense? It's a forecast. But I don't think it's wrong. So imagine, so what's really going to end up happening, and this is kind of my argument for that multi-purpose database thing, is the complexity of your environment is going to change. The complexity that you now have with lots of different data sources or data feeds coming in to your and feeding your application, you're going to need to make that go away. Because the complexity is going to shift to how are you combining your LLMs together and doing stuff there. And again, I choose to agree or disagree, but I think it's going to be accurate. So we're going to have all kinds of large language models. We're going to have, whether it's video, image, etc. And of course, they're going to be really expensive. So the other value proposition I end up putting out to my customers is, I started out, I said I'm really fast. So I do more work, right, with less resources. So you save money. I surveyed my customers all throughout the pandemic. Tell me how much you saved after you switched to Couchbase. They go, 53% of them said, out of about 200 respondents, they go, well, we think we save more than 50% on our TCO, on our operational costs after adopting Couchbase. And so my value proposition now is, well, you got to find the AI money somewhere. So that's one of the, offset the cost by simplifying your data architecture. That's kind of the argument. Oh yeah, then there's that mobile thing, right? Where's the best data? It's on your mobile device. A lot of your profile information, a lot of that situational information, location, what's happening, who's around you, what have you been doing, what are you looking up, the weather from the weather app. All of that is great, very, very rich information to put into as context to help that application do what it's supposed to do. Make whatever little pivot or whatever change it's going to do. That's why we call it adaptive applications. I stole that from the Forrester guy. Right? He's writing this paper about translytical applications. They have analytics and operational transactionality built in it at the same time. I'm like, I like that. I do that. And he's continuing to define what the requirements are as these things evolve. And much of it was, oh yeah, they're going to take on more information. They're going to end up being this kind of adaptable. But he leaves out Where do you think that stuff is going to happen? It's from the device, right? This is, your phone is, and out there, is everybody's favorite interface to technology. It's got the gold data in it. So we want to end up figuring out ways to safely, right, but use that information to give their experiences better and better and better, make it really, really slick. So having that ability to process vector capabilities or vector search and AI processing in your data center, in the cloud, in AWS, GCP, et cetera, but also do it at the edge, also do it on device, or do it on a chip that connects to the internet. All of processing your vector search capabilities at the device level, so that you create that low latency experience that we all expect. Right? The round trip might be too expensive. Don't trust the network. So that's ultimately where we're anticipating things to go. So like I said, and we're one of the few vendors, this is a final plug kind of thing, few vendors that actually has a cloud database as a service offering. It's called Capella. Has a mobile, embeddable mobile database, that's Couchbase Lite, and has an on-premises, you can download it, deploy it, use it for free, Community Edition or Enterprise Edition, all of which has vector search built into it. Right? You'll find the cloud vendors do it, but not on mobile or not on premises. Right? It's kind of one of the interesting uniquenesses of our offering. So here's kind of the conclusion of the bit. Integrate with all your favorite LLM interfaces like LangChain, Llama Index, Bedrock. Support all those different data access patterns. Have vector capabilities and conversations available wherever that experience needs to happen. Make sure that it's fast, flexible, and easy to develop. And then here's the funniest one. The first assertion that we made, because I'm this multi-purpose database, and I've got all these data access patterns, and we're adding vector search into our offering, the first thing I don't want to have happen, right, is a brand new category of databases pop up. Thanks, Pinecone. Right? It'd be like, vector search is a database category. No, it's not a database category. It's a feature of the database that you're going to see across the board. That's already happened. Right? You look at all the NoSQL vendors, Redis, ourselves, Mongo, the AWS offerings. We all have it in some form now. It's a feature, right? Not continuously going after the purpose-built notions, which were, for the last 15 years, have been right on the money. But now with these consolidations happening and all of that complexity moving to the LLM space rather than your data architecture space, it's a big driver for finishing off your application modernization or your digital transformation activities so that you can start to do this stuff. It's still early. Everybody's still a little hesitant to jump into this. And the dynamics of the market have continued to change over and over and over again. Kind of my concluding bits here of, well, JSON's a great format to do all of this anyway. You can store prompts, you can store prompt responses, you can store, in a side collection, all the hallucinations, as well as the attributes for, for a profile, et cetera. JSON is, that flexibility becomes more important. It's a mobile problem, as I said. It's actually something that, simplifying your data architecture will be significantly beneficial. And then, of course, having that real-time kind of calculator or real-time data that you're gathering from anywhere is also going to be very, very beneficial for these kind of applications. So, like I said, it comes in multiple flavors. I think this is the last one, right? It's the keys of all of this being successful ultimately. I'll also tell you some of the challenges that I'm that we're having right now I can describe the concept to you, but I don't have that many specific use cases for it yet, where all of these things are combining together. The Domino's example, right, hasn't happened yet. But I know, right, you're going to need high performance. You're going to need things like that JSON versatility to store whatever you've got and change and manipulate it as you need. You're going to need all the information happening on mobile. You're going to need this idea of talking to multiple LLMs at once. And you're going to need to figure out some kind of way to make your system pay for the expensive AI interactions that are going to go on. But this is, and again, this is my challenge. And please offer up your best kind of ideas of what are the features that are going to create, become these adaptations, right? I gave you it was the baseball game example. There's a handful of others, but whatever you're building in your organization or for yourselves, right? Whatever the context of that is, how would you combine things like a Gen AI conversation with location information, with situational information, and also provide, have the availability of, all these different data access patterns like location and search and, et cetera. That's what I'm, working for right now. Is like, I want to know who's going to be the first to break out of this whole notion of, I've got a chatbot that reads all my stuff and gives you the right answer when you ask. Awesome. But that's like generation 1 of Gen AI, right? I want to know what 2 and 3 and 4 are going to be. So that's kind of my plea to you guys is, what's your best ideas? So I think I'm done. Questions are good. Commentary is good.
Before we take that question, I just want to remind everybody, we're going to do the raffles right after the QA, so if you haven't already scanned the QR code, then kind of do it now if you want to win like cool prizes.
For these things.
Yeah,
Like
Commodore
that.
64,
The Commodore 64,
mug and all that stuff.
And I can't tell you, I really appreciate you guys coming out, and and it's really, my goal is all of this feedback, right? I want to know where you think, yeah, pretty right, or no, you're insane. So you had a question?
Yeah, you said, when you jump into all of this, can you define what you mean by all of this? Do you mean all of this as the RAG architecture model, where
Yeah,
you're just taking, or are you talking about jump into the Domino's example, or all of it, or all of it?
It's kind of all of it, but the jump in part would be, what are you doing even right now using vector search and RAG in any kind of application? Right? It's like, what feature functions are you putting into your system that require that similarity search? And tell me about that, because that's still interesting to me, because I liken this to when dashboards became a thing in the analytic world. This was a transition from your Excel-based reports or your paginated reports kind of thing. And then you're like, oh, wait a minute, there's a Flash widget that you can use that'll move and dynamically tell you some piece of information. That would work, but nobody had any idea how to do it and what to do. It's kind of like when it's kind of like getting a nice blank white wall like that and go, make some art, right? We're all going to stall for a long time before we decide on what the art's going to be on that wall. One of the reasons why you stage your house when you move out of it. Like, well, I got to show these people where the couch goes and where the television is. I think we're stuck in that situation right now. Also, kind of a little stuck in the cement on. I'm worried about sharing and hallucination. But my ultimate goal is to let's get beyond that. I want to talk about what's going to be the cool things next. So yes, all of this is. Tell me how it started.
Thanks.
So you guys support the JSON format?
Yes.
I think you guys consider a different binary format for the performance review. There are lots of binary format uses into the performance.
So JSON is kind of our interface for talking to applications.
Okay.
And when but you can also do programmatic key value access if you want things really fast. Skip the JSON. All of that again happens at memory speed, so we behave like a combination of Redis plus Mongo, right? So you get your super speed. We also wrap everything in transactions as you need. We've got 5 patents on transactions for JSON. But the JSON is kind of the common denominator.
Makes sense.
But when you're like, I just want it to be really fast, right? I've got ways to do that.
And the second sense that I think device-based AI model is very important. the thing you mentioned about this is because the speed.
Yeah.
The second reason, the major reason is privacy.
Yeah.
The privacy is the key because there's so many user data we cannot let them out of your device. So that's the reason the device-based LLM is very, very important.
Yeah.
There's also another reason why we're saying the model will be exposed, number of models, because everybody will have its own personalized LLM logging on the device. So that's the reason you get hundreds of thousands of LLM.
Yeah, I was going to say, so you want me to change my number to millions,
yeah,
right?
millions.
And ultimately get to, I like the idea, right? Because I think you're right in terms of the models are really ultimately going to become very, very personal and very likely on device, right?
Yeah, that's the reason there's a legal issue.
Yeah.
About the law.
And like I said, the lawyers are the first one who jump.
I'm sorry, I may have missed it when you were talking, but when you were talking about doing the vector search and all that, and is it that Couchbase has like an API that's reaching out to other models to like
Yes.
do that, or is it
you're
like the
right.
other way around where it goes into you go through it into Couchbase?
No, well, I did skip that.
I'm sorry, I missed
So
it.
no, but I'm glad you asked. So yeah, basically we store the information, but we're using LangChain or Llama Index or Bedrock to actually do host or facilitate the conversation with the model.
Okay. I didn't know if it was
Yeah.
like actually like internally, it's like got the model running inside of it.
Well, we haven't done that yet, but you could easily see, like especially on local devices, right? The model's going to be somewhere on the device too. So whatever interfaces are there, we're trying to be as sort of broad as we can be right now, because it's going to keep shaking out and get more interesting as again we start making more and more and more and more.
It seems the holy grail for the enterprise would be the RAGs. Would you elaborate your approach to RAGs more? So are you essentially proposing to use Couchbase as a data source for the RAG?
Yeah.
Or more?
Yeah, no, so I guess I'd say more. So we can, like Pinecone does, store the vectors. I do that, right? It's a brand new feature, but we do that. We modify our full text search engine with a whole new indexing path to make the vector access really efficient. So that's just one feature of our search engine. But then we also have the regular query engine, the analytic engine, the streaming engine are also work in conjunction with all of that. And so pitching the hybrid search kind of idea, where I'm drawing from vectors for similarity search, then adding in range queries for a range query extension for my price range, for example, and then adding in a geographic search, and then adding in all of these other types of data access patterns in that same string of information, all from the same data store. Right? That's kind of the value proposition that we're proposing, so that you can do all of these things without adding complexity or without having complexity in your data architecture, one system, rather than you have Pinecone for one thing, you have DocumentDB for your account profile, you have Elasticsearch for some of your searching exercises, you've got Elasticache to make it fast. Right? We're kind of the all-in-one solution for that.
The other database vendors, are they following the same suit or they're...
Yes, no, so yes, this notion of database vendors turning in and supporting multiple access patterns has been going on for 5 or 6 years. There's, the two vendors that have the most access patterns are like MongoDB and ourselves. And I'm not, again, I came from Neo4j, I like the graph idea a lot. So I'm not saying that Couchbase is like Neo4j in that functionality, but traversing an organizational hierarchy, no problem. But doing 17 hops across, for fraud detection and seeing like you happen to be traveling, in a brand new country, and perhaps you left your credit card at the restaurant, kind of thing. I'm not saying we're doing all of those kind of hops for graph. We have kind of an ingenious way to do time series data that InfluxDB doesn't really do. We put it in a JSON array. So we're taking a lot of the best feature ingredients that we support and then adding our data access patterns to that. And historically, the way everything has evolved, the characterization of all of this was multi-model, right? There's a columnar model, that's Cassandra. There's a key value model, that's Memcached and Redis. There's a document model, that's MongoDB. But all of those things are convergent. And so the model part was really how each database writes all their data to disk for efficiency's sake. Right? They all wrote it out in different ways. But the idea of having a fast key value store as kind of the foundation for a lot of that has also taken place. That's, Mongo's done it, Aerospike's done it, we've done it, Dynamo's kind of like that. So they're all starting to converge on each other, which is a natural evolution of things, right? Your phone used to be a daytimer, right? And a phone, and a camera, and everything else, right? Our pockets were stuffed, but now it's not. So technology evolves this way, but so does coral reefs, and so does pretty much everything. And that's what's happening in the database world right now. And so as I talk to the Gartner Forrester people of the world, they're recognizing that too, right? They're describing everything as, yes, it's all becoming, every database is taking on characteristics of every other database. I think we're pretty far along. Unusual for me to say, because I've always felt like, Couchbase was 5 years past building a database as a service, for example. We were late, but we're catching up, right? But then the other characteristics of just scaling, like crazy, and supporting these big customer examples that we've got. I'll race anyone. And now I've got all these different data access patterns that actually make sense for this particular AI style problem. So it helps kind of create the urgency of these applications to look at, well, where's the AI that I could put in something that I have right now, right? Where would it benefit beyond the chatbot? So that, and arguably almost every application is going to be evaluated that way. So you're going to say, well, where can I put it in? That's a lot of applications. It's kind of like the Y2K problem, right? Without the urgency of the date. But every application is going to get looked at for adding AI to it in some form. And ideally, right, to support all these different access features when you need them, we're a good solution for that.
When you show the hardware search, so if you want to support the vector search for a certain field, like the description you show or the title, so you just add a field for the description embedding vector or title vector into, then you do the vector search. Do you actually, what time you support the top level keys, or you also support the embedded?
Yeah, we support the embedded ones as well.
Okay.
Support the top level keys in the vector search as well as all the vector embeddings. Yes, that's what we're storing.
So if the, because Mongo they only support the top level.
I know.
So.
So yes, I know.
Also, how does would that change the size of the document, impact the performance of that?
So yes, you might have huge documents. The fun part with Couchbase is you could have a series of vectors be supported by 100, 1,000 documents, right? If you need it. And each document is indexed. So both from the vector side, but also through the other global secondary index mechanisms that are built into Couchbase. So the mix and match capability there is pretty strong. So my stupid final pitch is, you guys, Couchbase is the coolest database you've never seen, right? It's a really, really good product, and it lasts 10 minutes, and you're like, wow, he was right. You'll know it instantly because you know SQL. You'll fuss around with it and do something really slick, and then it'll scale. Yes.
Yeah. Can you talk more about how would you design the indexes for like thousands, hundreds of documents? And those documents are like not just text; they have tables and charts. How would you?
Well, the documents typically have text in them, right? We're not storing we're storing links to the charts, right? If it's a JPEG or something like that. but we're still storing the data for the chart, and then we'll display it as as a graphic when we're reproducing it. But the JSON is basically it's all going to be text, right? We need to be able to read it. But the way we're indexing everything, we've got a document index that is kind of the top level indexing mechanism, and then for any value that's inside the document, we basically break the whole document into however many key value pairs we need, and that goes into our key value store. So even arrays, right? Every member of an array gets its own index ID when we're parsing all of this thing out. If you need that particular indexing, Mongo, for example, indexes like the first value of the array, but then doesn't go further. So all of our global secondary index features, you can have as many as you want. Right? Your trade is going to be, they might take up a lot of space, but as you need them, right, you can always create them. Dynamo has a limit of like, I don't know, 20 or 30 per table. Right? So it's extremely flexible for how to optimize things. And then we have that index advisor feature, which when you have a query that you're going after the data, it'll tell you what to build if you haven't got it built. And then we've got a cross-base optimizer for the query engine that will also make sure that all of your access activity is as fast as it can be, right? And we'll show you the whole query plan and how everything is laid out as you're doing it, so you can understand what's going on. But we moved to the cross-base optimizer from a rules-based one about 2 or 3 years ago. And for JSON query kind of stuff, nobody else does that, right? That's a unique feature of Couchbase. It's patented. Right? That's been a big area of focus for our engineering team. It's like, make the SQL++ really, really robust. And if you want to wrap it in transactions, go ahead. Right? It's got a lot of features in it. It's a slick database. Been around databases for a long, long time. And it's a really, really fun one to see kind of take off right now.
So if my understanding is correct, you are going to parse the documents like CSV.
Yeah, kind of.
Column and
Kind
row.
of, yeah.
And
Even when there's documents embedded in documents and arrays embedded in those documents and documents. But yeah, in essence, we parse it all out and then we reassemble it all as you're requesting it. We store it in this key value database called Magna that I described earlier, where it's super efficient now, understands how the document structures are, and then reassembles it as you're talking.
how about the accuracy? Let's say I wanted to look through hundreds of long documents, and I want it to give me some data or trends about the specific section that I want to know in the document. What is the performance of
That's
it?
sort of what the column store is all about, right? Is to address that particular kind of use case of how about if I just, when I'm looking for specific data elements, but a lot of them, right? The column store is designed to facilitate that. And that's one of the newer capabilities we put into it, into the database. But it's also the first time we went and said, all right, well, we'll have all the operational information on one side and columnar storage on the other side for big scale kind of things.
Will it be able to also look at the table
Yes.
data and also summarize it?
And also
take those
summarize it
into
and also,
consideration? And the data would be accurately returned, or?
to my knowledge, right, in front of what, 25 people, right, I'm going to say, yeah, I think so. But I might be wrong, but yes, I think so.
But it's a
Yeah.
table that should be correct.
Yeah.
Is there any limitation, or like how many questions I can ask?
Yeah, so there are document size limitations, but then we roll over to another document that's about 2 megabytes is our regular document size. On the size of a table that we're running through everything, because it's still brand new capability, I don't have how big could it go kind of thing. And then we get into like how much disk space are you taking up and how many nodes you run managing the disk and all those things. It's hard. It's like what's my my upper limit? It's hard to say.
Okay. Thank you.
Good question.
The documents, as you store them in the database, do you separate the...
That's what I just said, I parse everything.
No, I understand,
right.
but each document, together with the data, the attribute of the JSON document, they are all stored together in the database.
Yeah.
So actually, the schema is repeated in each document again and again.
Yeah, but the schema that we're storing everything is like 3 columns. It's, you know, it's whatever that ID indexing mechanism is, then the attribute, the field name, and then the field value, where it lives. And then all of that rolls up to your document ID. And then as everything changes, we do like a compare and swap, right? Document, we have like a document increment counter that keeps track of how everything changes inside of the thing.
We have time for like one more question, and then, but don't worry, Jeff will
Yeah,
be
and also-
for one-on-one questions afterwards, but one more general question. Yes?
I think it's related to that. Like, there is any version control mechanisms about that, about the documents, and like how it should keep the consistent between the versions?
Yes, there is, right? And that's what I was saying. There's a control. The way we do it is CAS, right? Compare and swap, and we're always incrementing any change in the document, right? Is logging another increment of that ID, and then and it's all timestamped. So all of the things that we're doing when doing a synchronization, doing a replication, doing a write to a replica, all of that is also getting evaluated for, is this what I expect?
And what, maybe my question is like, how this reflects to the data?
Good question. I don't know yet. Right, but yes, all right. But this is the thing that I want to have happen, right? Is I want those kind of questions so that I feel like, all right, beyond the imagination, right? We're starting to get into how the heck are you going to do that, right? I really like that. So I will definitely end up taking it up and being like, okay, here's one of the good ones that I got.
I remember my experience with Couchbase was like, I really like the way that the underscore rag, manage the rags and so on. And then I was thinking.
Now remember, right? Couchbase and CouchDB are like cousins now, right? Yeah, but again, it's slick, right? It's, if anything, we've got free stuff. Try it out. Tell me I'm wrong. Right? I'm readily accessible. But it's like that feedback is what I'm craving. I want.
All right, Jeff will be here for one-on-one questions, but right now we're gonna give away stuff. So like, I know you all want raffle prizes, right? Thank you so much, Jeff Morris. Where's my soda? Soda's right here. All right, come on up and let's do this. We're gonna go. Well, it's randomized, right?
It is totally randomized. So I've got the list here. So that's the cutoff has been done.
All right. So here's what we're gonna do. He's gonna name 4 people. We're gonna give it away in order of Power Bank 1. I guess then we'll do the Yeti. Then we'll do Power Bank 2, and then the big grand prize, the Commodore 64.
That's it.
Why don't they write Commodore? I guess that's a copyright thing. It says C64, but I'm sure that is a Commodore 64 in modern format. So
it also comes with games as well. So you're ready to go as soon as you get back to your place. You can deploy a little bit like Couchbase. That wasn't a plug.
All right, let's hear the first name.
Okay, so the first name and the winner of Power Bank 1 is Pavel Levin.
Pavel?
There we go. All right.
All right, for the awesome Yeti Cup
is Umesh Sai Garam.
All right, Power Bank number 2.
Power Bank number 2 is going to Vincent G.
And now the big grand prize, the Commodore 64, aka C64.
It's me.
I'd like to win it too, but we're both disqualified.
The grand prize is going to Devinder Sandhu. Good job.
All right, thank you so much for coming. Thank you again, Jeff Morris. Jeff is here for one-on-one questions. Coming up and just come up and talk to him. Also, I think there's still a little bit more caviar outside. You can help yourselves. We're going to wrap up at the end, so any food on that table, you can actually take it home with you as long as the food on that table. Thank you all for coming.
Thank you.